I'm going to sign into my account. So I'm going to go ahead and sign in using root account credentials. So once I've logged into the root account, till now all the services that we have seen are global in scope. IAM is global in scope. S3 is global configuration in scope, but then buckets are regional. CloudFront is global in scope because it utilizes edge locations. But right now when we look at EC2, EC2 is region scope. It's not in global scope. So when you choose EC2, you can also choose any other region that you want to launch your virtual machines. Okay. So we are going to go with launching an, okay. So before launching an instance, okay, let's just look at this dashboard. So in this dashboard on the left side, you have under instances, you have spot, you have reserved, you have dedicated host. These are the three pricing models that we looked at, and any instance that you launch right now, that comes under the on-demand pricing model. Okay, so whenever you're demanding, you're getting that capacity. So when you go through this wizard of launching an instance, it's called as on-demand pricing model. And then over here you can see AMIs. So all of your custom AMIs can be listed over here. And then you can also see under Elastic Block Store, we have volumes, snapshots, and lifecycle manager. Okay, so these are the configurations that we are going to look at today. So let's go ahead and look at reserved instances first, and then I'll show you as to how to go ahead and launch a virtual machine. Let's look at these three. So let's start with reserved instances. So when we saw the pricing model about reserved instances, we saw that it should be, you should commit to a particular time period, which is 1 year or 3 years. So let's go ahead and purchase a reserved instance. So you can see over here, you can choose the platform that you want, whether it's Linux or Unix, or whether you want it with an additional software like SQL Server, or you want to go with SUSE Linux or Red Hat Enterprise. So you get it, right? So these are the operating systems that you can choose. I'm going to go with Linux and Unix. You can also choose your tenancy, which is going to be default or dedicated. Okay. And then in your offering class, you can choose whether you want convertible or standard. I didn't speak about this in the slide, is because this is again not part of the exam. But then when you go for standard offering class, it means that in this 1 year period of time that you're going, 1 year or 3 year period of time that you're going to commit to using this capacity, you will not be able to change the capacity, which means you will not be able to change your RAM, which means you will not be able to change your operating system, which means you will not be able to change your virtual CPUs. But then if you go with convertible, you will be able to change these within the term commitment period. So you'll be able to change your operating system within the year. You'll be able to change your virtual CPUs or your RAM. So if you want to go ahead with that kind of an offering, you can go with your convertible offering class. But if you want to commit to 1 year or 3 year period and you don't want to change any of your configuration, you can go with standard. Okay. So that means for the entire commitment period that you're going for, you will never be able to change the capacity of your virtual machine. But if you go with convertible, you will be able to change your capacity. So I'm going to go with standard over here, which means I'm not going to change any configuration for the term period that I'm going to commit for. The term period I can choose between 1 year or 3 years. So I'm going to go with 3 years. And then you can see I can choose all the instance types that are listed over here. You can see the instance type starts from micro, nano, small, medium, large, extra large, 2 into extra large, and so on. Okay, you can also see big instances like 24 into extra large. So while we launch an instance, I'll show you as to how much memory and CPU these virtual machines have. Okay, so I'm going to go with the smallest one, which is T2 micro. And then under payment option, you can see that we have 3 options to pay for reserved instances. One is doing the entire payment upfront or not doing any payment upfront. And the second option or the middle option is paying the partial money upfront, and then the rest of the amount you will be paying it on per month basis. Okay, so you can go with all upfront value, you'll get the maximum discount. So I'm going to search. So they are giving you a term period of 36 months, which is 3 years. They are giving you an upfront price of $115 for T2 micro. Okay, so generally when you go with T2 micro's pricing, let's just compare it. T2.micro price, on demand price, something like that. Okay, so you can see that T2.micro's on demand price, when you open this and you scroll down, T2.micro's on demand price is $0.0116, okay, per hour. So when you go with $0.0116 per hour, into 24 hours into 30 days for a month into 12 for a year into 3 for 3 years. So you can see that you're going to pay at least $300 to run T2 Micro in on-demand pricing for 3 years. But then just think about this. You're paying only $115 if you're committing for a reserved instance of the same capacity for a 3-year period. So which means you get a very good discount. Instead of going with the on-demand pricing of $300, you are committing towards a 3-year commitment period and you get discounts. You get $115 only that you're going to pay, right? This is beautiful. So this is reserved instances. Okay. So you get that. So now if you go ahead and add it to the cart and then you go ahead and view the cart and then you pay for this reserved instance, automatically that reserved instance will be provisioned in your account. Okay. So that's it about reserved instances. And when it comes to dedicated host, we saw that dedicated host is the entire host that is given for you. Okay. So on that dedicated host, you will be able to launch any other virtual machines that you want to launch also. So right now, dedicated hosts you will not be able to launch because you will have to talk to AWS support in order to even increase your limits to launch a dedicated host. But you can read about the description, and we spoke about this also in the pricing models. So he says that you have visibility over how your dedicated hosts are utilized, and you can determine as to how many sockets and cores are being installed on the server. It allows you to bring your own license scenario. So if you already have a software that is complying to certain licensing policies and so on, you can go ahead and install that software on a dedicated host. So the entire cabinet is given to you. You are not sharing your hardware in the background. Okay. But there are certain on-demand use cases wherein if the availability zone, in that availability zone, you will have a server. You using a particular AWS account and launching a virtual machine will be on that server. Any other person having another AWS account launching a virtual machine can also be on that same server. But you are isolated at the hardware level. Okay. And you are isolated at the account level. You are isolated at the VPC level of that region. Okay. So let's go ahead and look at launching an instance. Okay. And then while launching an instance, we will talk about Spot. So I'm going to click on launch instance. So you have to remember all of these configurations frame by frame. The more you start creating virtual machines, the more comfortable it will be for you. So the first screen that he is asking us to do is creating a virtual machine and choosing the AMI or the Amazon machine image. So you can see over here, when you scroll down, you have Red Hat Linux, you have SUSE Linux, you have Ubuntu, and then you have Microsoft Windows Server, and you have certain deep learning AMI, which also includes all of these softwares installed within that. Okay. So you can just scroll through all of these AMIs, but I'm going to go with the basic one, which is Amazon Linux AMI. And over here, you can see it is of type SSD volume type, which means it's EBS backed. And you can see it's not instant store back, it's EBS backed. And then you can see over here, the default image includes command line tools like Python, Ruby, Perl, and Java. So it also includes repositories like Docker, PHP, MySQL, PostgreSQL, and other packages for you to install using those repositories. And you can see that the AMI ID is a distinguished ID, a distinct ID that is denoted to an AMI in this particular region. So if you take any other region and you see the same AMI in that region, the AMI ID alone will be different. Okay. And you can also see over here, so an AMI is nothing but an operating system, an application server, and applications already installed onto it. Okay. So we are going to go ahead and select this operating system, which is 64-bit operating system. And over here only you can choose your configuration of virtual CPUs and memory. Okay. So I'm going to go with T2 Micro, which is 1 virtual CPU and 1 GB of RAM. But then if you scroll more down, you can see that there are big instances like 96 virtual CPUs, 384 GB of RAM. So these instances are very costly. It costs $4 to $5 per hour to launch these instances. And you can see these instances are categorized on general purpose. There is also another category if you keep scrolling down for compute. There is another category if you keep scrolling down for FPGA. You have GPU instances. You can just click on them and see as to what is the definition of using GPU instances. You have memory instances in the R series, and you have memory instances in the X series. Okay, so you can just keep scrolling down and you can see, okay, what are the different instance types, which kind of configuration you want to have. Generally for an application server, we are going to only go with T2 micro configuration. And at the same time, to stay within the free tier eligibility criteria, we will go with T2 micro configuration. So depending on your workload, you can choose any kind of configuration that you want. Okay. So under configure instance details, you can see over here, I'm going to talk only about certain parameters over here. So you can see the number of instances that you want to launch. You can launch 1 or 2 or 3 and so on. I'm going to launch only 1 right now. And the purchasing option, you can request for spot instances. So even at spot instances, you have very good discount rates, because we saw that the price of T2 micro itself in on-demand pricing is $0.0116. You can see over here, the current spot price is 0.0035, which is much lesser than $0.0116. So now I'm going to bid for my price. I can say 0.040 is the price that I'm willing to pay. So now if the spot price is lesser than my bid price, this capacity will be provisioned for me. If at all, at any point of the day, the spot price goes more than my bid price, AWS is going to terminate that instance. Okay, so this is the concept regarding spot pricing. Okay, so I'm going to disable this. I'm not going to go with spot right now. I'm going to continue with on-demand pricing. Okay. So next, you can see in the network portion of things, you have a VPC already selected, you have a subnet already selected, you have an auto assigned public IP already selected. We are not going to look at these configurations right now. Okay, we are going to keep these as the same. And then when it comes to an IAM role, you can see over here, while you create a virtual machine, you will be able to associate an IAM role with this virtual machine. Okay. And then when it comes to the shutdown behavior, you can either choose whether you want to stop your virtual machine or whether you want to terminate your virtual machine when you shut it down. Okay, I'm going to leave it as stop itself. And then to protect against accidental termination, you can go ahead and choose this option, which means no one can terminate your virtual machine until and unless you disable this particular option. Okay. And then when it comes to monitoring, it uses a third-party service. It uses another service called as CloudWatch. Okay. So CloudWatch is a service that monitors your virtual machine. So it gives you metrics along the lines of what is the CPU utilization, what is the network in, network out, how many packets have come into your network, how many packets have left your network, how much disk write bytes and disk read bytes metrics that has been done on your virtual machine, and so on. So there are a lot of metrics that are being given to us by CloudWatch. Okay, so these metrics are delivered to us on 5-minute basis. But if you want to enable detailed monitoring, which includes more charges, you will be getting that in a granularity of 1 minute. Okay. So by default, if you leave it like this itself, you will get 5-minute interval metrics from CloudWatch for your virtual machine regarding CPU utilization, network utilization, disk utilization, and so on. Okay. And then we are not going to talk about tenancy or elastic inference, but then in tenancy, you can either launch this virtual machine on a dedicated host, or you can launch it as a dedicated instance, or you can share the hardware. So which means when you go with shared hardware, it means that in the background, in that availability zone, in that server, in the availability zone, this particular capacity is going to be provisioned for you, and any other person in any other AWS account is also going to share that same server. Okay, so that means many people are sharing that server's capacity. Okay, in that particular availability zone. So in the advanced details, you will be able to go ahead and present your own bash script. So you can write your own bash scripts over here. Okay, so I'll show that as a separate lab. So next we will walk through the setting of adding an hard disk. Okay, so under hard disks, you can see that the root volume, which is where your operating system resides, AWS allows you to choose only provision, magnetic, and general purpose. Okay, we didn't speak about magnetic storage. You don't need to concern yourself with that because it is going to be decommissioned soon. Okay, but then you can see that the SSD and HDD that we spoke about was general purpose SSD and provision IOPS SSD. Okay, so over here you can also go ahead and choose to whether you want to encrypt this particular root volume using AWS KMS, which is key management service. And at the same time, if suppose you terminate your virtual machine, do you want to keep the volume or not? That setting is determined by this delete on termination. So if I uncheck this flag, it means that if I terminate my virtual machine, I will still have access to the underlying hard disk. If I enable this option, it means if I terminate my virtual machine, I'm going to also delete this particular volume. Okay, so I can also choose to add any new volumes. So when I choose to add any new volumes, I will also get the cold hard disk and throughput optimized hard disk. But for the root volume alone, AWS recommends using general purpose SSD and provisioned IOPS. So within the free tier eligibility criteria, inclusive of all the volumes that you use, you can get up to 30 GB of storage. And after you utilize 30 GB of storage, you're going to be presented with cost. Okay. So I'm not going to add any additional volume. I'm going to keep it as the root volume itself. Okay. And then I'm going to add tags. Tags are a way to denote, like how we saw it in S3, tags are a way to denote as to which project this particular virtual machine belongs to. So I'm going to give a name for this. I'm going to call it as a web server. And then I'm going to also say the project name that this is associated with this Caliber project. Okay. This virtual machine is associated with. So if you go ahead and download your cost report for that particular month, you can see as to how much these resources cost for this particular project. So for all the resources of the project, have a common key value path that you associate with all the resources for that particular project. Okay. So under configuring a security group, this is where you go through the configurations of your firewall. What traffic you are going to allow into your virtual machine. And by default, the traffic that you allow into your virtual machine only will be allowed, and all the other traffics will be by default rejected. So I'm going to create a new security group. I'm going to call this as web server SG, for SG as short form for security group. And then you can see over here, I can keep adding any protocol that I want to allow. So there are default protocols that AWS has given us. So one such default protocol is SSH. So when you go with SSH, it is not recommended to open SSH to the outside world, which is the outside world is denoted by 0.0.0.0/0. We are going to tie it down to my IP address. So my IP address in the sense, my public IP. So if I go over here into Google and I type my IP, you can see over here 49.207.135.217, 49.207. That's the way they have beautifully written their code in the background to automatically detect your public IP. So I'm going to add one more port, which is port HTTP, and I'm going to leave it as open to the outside world. So if suppose I convert this web server, okay, and I install a web server into this virtual machine, okay, then I serve an endpoint page, which is an index.html page. I want to be able to access that index.html page on port 80. Generally, all web servers run on port 80. Okay, you have only certain web servers that run on port 8080. So if you go ahead and expose any kind of application, always ensure that that port is open in your security group. If you're not able to view the website, it means you have to go back to your security group and modify it to allow that particular port's access. And whatever you allowed on inbound, automatically that traffic will be allowed on outbound. That's why security groups are stateful in nature. So whatever traffic you allow on inbound will be automatically allowed on outbound. So let's go ahead and review and launch. Let's go ahead and launch. So this is the concept of security. This is the third layer of security within your VPC. This is called as key pairs. So key pair is nothing but a public key and a private key. The public key is already associated with your server. You only have to provide your private key, and only if your public key and private key matches, you will be allowed access into the operating system of this virtual machine. The operating system that we chose was Amazon Linux AMI. So I have certain keys with me already, but then I'm going to go ahead and create a new key. I'm going to give this key a name. I'm going to call this as web server NV. Okay, always use a same key for across virtual machines if possible. Okay. So when you create a new key pair, you will still not be able to launch the instance. You can only download the key pair and then launch your instances. Okay. So to reiterate what key pairs are, it's nothing but a private key and a public key using RSA encryption strategy, 2048 bits. What happens over here is that Amazon internally stores that public keys content into your virtual machine, and you have to provide your private key. So therefore, we are going to provide this key while logging into the operating system of this virtual machine. Let's go ahead and launch this virtual machine. So when you click on view instances, it takes you back to the home page where you can view all the instances. I'm going to type web server. Okay, so right now the instance state is in pending, and these are the instance metadata. That is data about the instance. So you can see over here, it automatically got a public IP. It automatically got a public DNS. This public IP is the IP that we use to access this particular virtual machine from the internet. The private IP is what this virtual machine uses to talk to other virtual machines within the VPC. Okay. So you can see by default, we didn't still speak about VPC, but we will look at that. So the public IP is what you use to talk from the internet to this virtual machine, and the private IP is what it uses to talk to other virtual machines within the VPC or within its network. And you can see the key pair that we associated. We didn't associate any IAM rules still, okay? And you can see that a network interface is automatically been allocated to this virtual machine, which gives you these IP related details. Network interface is nothing but a network card. You can imagine it as a network card in your CPU, which gives you that network configuration like a private IP and a public IP and so on. So the security group that you configured that allowed access on port 80 and 22 are associated with the network interface card. Okay. So you can view your inbound rules over here. You can view port 80 that you have given to the outside world and port 22 which you have logged down to your IP address. So you can see that on-demand capacity has been provisioned to us within minutes, and this virtual machine is in the running state. So now I'll be able to log into this virtual machine. So what I'm going to do is I'm going to copy this key pair into a common folder that I generally have for key pairs. So I'm going to go to downloads. I'm going to take that key pair, copy, go to documents, MacBook files, key pairs, paste it over here. So now once I have done that, I'm going to go ahead and use terminal. Since I'm using a MacBook, I'm going to use a terminal to go ahead and do a login into that virtual machine. So I'm going to zoom this so that you guys can see. Okay. So the command that you use to go ahead and log into the virtual machine using a MacBook is going to be SSH EC2-user, which is the default username for Amazon Linux operating system. So you will have to remember the default usernames across operating systems. So for Ubuntu, it is Ubuntu. For CentOS, the default user is CentOS. For Amazon Linux AMI, it is EC2-user. For Alpine operating system, it is admin, ADMIN, admin. Okay. So you're going to, since we have used Amazon Linux AMI, we are going to go ahead with EC2-user. Let's go ahead and get the public IP of that server. So let's go ahead and copy the public IP. Since I'm accessing it from the internet, I have to use the public IP. I can't use the private IP because it is within the VPC. Okay. And then I have to specify a flag, which is -i. And then I have to specify the path for my key pair. Document, MacBook files, key pair, and the file name that we gave was web server nv.pem. So immediately when you do this enter, it's going to give you a small error. That error is going to be that your key pair is not protected. Okay. So generally when you face an error such as this, you will have to modify the permissions on the key pair using the chmod command. Okay. To restrict only read access to that key pair. Okay. So I'm going to do chmod 400 and I'm going to paste this entire link to my key pair. Okay. So once you have done the chmod 400, which means you have limited the privileges on that key pair to only read access, you can now execute the same command and then you will be within the virtual machine. So when you execute the same command right now, it states EC2 Amazon Linux AMI, which means success. You are within the virtual machine. So you can see over here from Akshay's MacBook Pro, Akshay PK, it has gone to EC2-user at the private IP 172.31.93.158. 172.31.93.158. So since you provided your key pair, where does AWS go ahead and associate the public key? That's something that you have to think about, right? Because AWS places the public key somewhere and then you provide the private key, right? But where does AWS store the public key? It stores it in a folder called in the //.ssh. Over here you can ls and you can see under the authorized keys, if you cat authorized keys, you can see this is the public key that AWS has automatically associated with your virtual machine. You are providing your private key, and until that private key is matching with this public key, you will not be allowed access into your virtual machine. So since we provided everything in the right manner, we were able to access the virtual machine. Okay. So let's go ahead and terminate this virtual machine. Okay. Or let's use it for another purpose. Okay. Let's go ahead and use it for the EC2 instance metadata. How do you view the EC2 instance metadata from your virtual machine? So I'm going to go back to CD home slash EC2-user. Okay. So let's go ahead and do the EC2 instance metadata. So all the metadata that you're going to see over here, all these metadata, you will be able to view it from within that link local address, which is curl http // 169.254.169.254 latest /meta-data/. So you can see you can get the details regarding the AMI ID, the host name, the instance ID, the instance type, the public IPv4 address, and so on. So let's find out what the public IPv4 address is. So type public -IPv4, hit a slash. So automatically it gave you the public IP, which is 52.87.223.89. 52.87.223.89 is the public IP. So you can see that you can access all the instances related details or metadata just by curling this particular URL from within the instance, from within the operating system of the instance. Always remember that. You cannot curl this or you cannot hit this endpoint from your browser. It has to be from only within the server. So any server that you launch, irrespective of what operating system it's running, you can do a curl request to this endpoint from within the operating system and you will be able to get all these details. So you can even output this detail to a file. I'm going to output it to a file called publicip.txt. So now if I go ahead and view the contents of that publicip.txt using the cat command, you can see that we have written that output to a file. Now this file, I can go ahead and upload it to S3. So let's do the upload to S3. But before that, since the Amazon Linux AMI also comes with your AWS CLI, let's do AWS S3 LS. It's not able to access because there is no credentials that have been configured. So that means there are two ways to access S3 right now. One is by doing AWS configure and presenting your access key ID and secret access key. And then that user should have access to S3. The other way to go ahead and access S3 is through IAM roles. Because generally creating access key ID and secret access key is not a good practice. We will go ahead with IAM roles. So let's go ahead and create an IAM role right now. So services, let's go to IAM. Let's go to open it in a new tab. Let's open up IAM. Let's go to roles. Let's click on create role. So over here under create role, you can choose as to which service you want to create that role for. That service that you want to create the role right now is you want to allow EC2 instances to call other AWS services on your behalf. So you're going to choose EC2 right now, and then you're going to click on permissions, and then you are going to choose the S3 full access policy. So that means this role which is going to be associated with that EC2 instance that we have running right now, we are going to attach the role to that EC2 instance, and that policy that is going to be attached to that role is going to give that instance full access to S3 service. You can also create your own customized policy like how we saw it in IAM and also provide that policy as the access over here. But then just for simplicity's sake, we are going with full access. I'm going to click on review. I'm going to state this as EC2 S3 administrator access policy or administrator access role, because this is a role, right? It's not a policy. The policy that we have attached is Amazon S3 full access. So always give meaningful names for your roles and descriptions. So once you create the role, go back to EC2, go to actions, click on your server, go to actions, instance settings, attach replace IAM role. So this feature was brought out in the year 2017, wherein not only during the creation of a virtual machine, you will be able to attach an IAM role. Even after that virtual machine has been created, you will be able to attach an IAM role. So I'm going to click on attach replace IAM role. I'm going to choose the IAM role over here, which we gave it as EC2 S3 administrator access role. So now this virtual machine is going to get temporary credentials to access the S3 service from that IAM role, because the policy has been attached to that IAM role, which states you have full access to S3. Click on apply. Now go back to your virtual machine and type AWS S3 LS. You get all the buckets. Previously it's specified unable to locate credentials. Now since you attach the role, you are able to access all the buckets in S3, which is beautiful. Now let's do one more thing. Let's go ahead and run a web server within this. Since we have access to S3, let's run a web server within this virtual machine. So this virtual machine is like your computer. You have to install some of the softwares that you want. So I'm going to install a software called HTTPD, which is a lightweight web server. Okay. So onto this virtual machine, I'm installing a web server. Okay. So I'm installing that web server using the yum package manager. So while working with Linux, you should know what are all the package managers associated with the different operating systems. So yum package manager is associated with Amazon Linux AMI. apt-get is the package manager that is associated with Ubuntu. For Alpine, it is apk. Okay, so you have to remember these package managers so that using these package managers, you will be able to install additional packages. This -y, I'm stating that if I don't state this, it will ask me for a prompt of yes. Okay, so right now it's not able to detect because it's saying you need to be root to be able to perform this command. So right now I am EC2-user. To elevate my privileges to super user, I'm going to say sudo su. So from EC2-user, I have become root. Now if I go ahead and install HTTPD, it is going to go ahead and download all the packages regarding HTTPD and also install other dependency packages. And then it's going to ask me whether this is okay or not. Instead of specifying y over here, that's why I specified -y while doing the install command itself. So once this package has been installed, you will get access to a particular folder called var www.html. So within this folder, if you present all of your front-end assets like your HTML, CSS, and JavaScript files, it will be served by the web server called HTTPD. Okay, so let's do a copy command from one of the AWS S3 buckets. Okay, so we are going to say AWS S3 ls, and within which we have a static website hosted bucket called dp static website hosting. And this bucket contains only one file that is called as index.html. How do you find that out? AWS S3 ls S3 / dp static website hosting. So you're listing the contents of the bucket using AWS S3 ls and specifying the bucket name. So you have an index.html that is present within this bucket. This index.html that is present within the bucket in S3, you're going to copy it into the folder called HTML, okay, which is within your server. Okay, so to do that command, we are going to state AWS S3 CP for copy -- recursive to copy all the files. But since we have only one file, we will still present this flag just to show you that there is a flag to copy all the files one after the other. And then you present your source, which is dp static website hosting, which is your source bucket, and the destination is going to be this virtual machines var www.html directory. Instead of specifying this entire directory, since you are already within the directory, you can also specify dot, which means the current working directory. So automatically it has copied that, it has downloaded that file to this current working directory. So if you type ls over here, which is to list all the files within the directory, you can see we have an index.html. So now if we go back to the console and get the public IP address of this particular server. So if we say web server, and then we get the public IP of this server and paste it on the browser, always remember that you have given access in your security group for port 80 to the outside world. So you should be able to access that on port 80. You can go ahead and click on enter. Nothing is happening. Okay, so if everything goes well, we are not learning something new. So what mistake has been done is we have installed the web server, but we haven't started the web server. So we have to say service httpd start. So once we have started the httpd server, go back to the browser, do a refresh action. We can see that the website which is present on the index.html has been presented on the web servers on the virtual machine's public IP address. So within this virtual machine, a web server is running. That server serves this particular web page. This web page has been downloaded from S3 from a bucket called as dp static website hosting. Okay, using an IAM role. So we saw the concept of IAM roles also over here, wherein EC2 as a service was able to access S3. We also saw how to install a basic web server onto the virtual machine, and then how do you start